Hello everyone. This will be a new series where we'll start solving lead code questions, one question a day or two questions a day. I'll upload each question, so this will be a recorded series rather than live. Uh, we'll start from the very basics, which is two sum, and I hope I can continue this for at least 2 or 3 months and go up to more advanced topics like graphs and DP and bit masking and whatnot. So without further ado, let's go ahead and start with the most simplest question of all. So this is lead code. I'll add these solutions, the brute force methods I'll explain, and this ultimate solution that I use finally will be uploaded in a GitHub registry, which I will link in the description or in the comment section below if you want to go ahead and check it out. So that's a work in progress. We'll learn a lot. Basically, I will learn a lot, and I will hope that you stay along for the journey and you also get to learn something from this thing. And we'll try to avoid AI as much as possible because obviously we want to learn. But if it is very necessary to you Google some stuff or use ChatGPT, in that case we might be also using that. So let's begin. This is a very simple question. I've solved it quite a lot of times. Just give me a second while I log in. hmm Let's log in. If I log in, you can see I have solved this question quite a lot of times. So I'll just change the scene. All right. So here is our question. We'll try to do that in C++ and or Python. Java is obviously something that I have not worked with, so I'm not very comfortable with. But yeah, let's see. So it says you're given an array of integer nums and an integer target. Return indices of the two numbers such that they add up to target. Let's go and look at an example. Nums 2, 7, 11, 15 and target is 9. So obviously 2 plus 7 is 9 and their indices are 0 and 1. You may assume that each input would have exactly one solution and you may not use the same element twice. So this is a very important thing, that each input would have exactly one solution. So there is a solution, there is nothing like okay the output will be a blank array or there will be multiple solutions. Since this is an easy question and you can return the answer in any order, so if I return 0 1 or 1 0, it will be okay. Let's go ahead and let's look at how will we do that. So this question is obviously two sum, so I'll say two sum and it's question number 1 on lead code. Let's see. So we'll take the first example where it was input was 2 7 11 15, yes, and our target was 9, right? So what we can do, the most brute force approach is we come here, we take I and j as 2 pointers, we point I at 2 and then 7 through 11 we go iterating via j. So first we have 2 plus 7 and then we check if it's 9, 9 true, then we print out I and j, then we go 2 plus 11 which is not 9, so we don't do anything, then we go 2 plus 15 which is 9 again, then we print I and j. But in this case, since we already know that the input will have exactly one solution, as soon as we get one solution, what we can do is we can break or we can return. But suppose if it was not the case, suppose if it was 11, say 15, 7, 3 and 2, right? If this was the array, what would have happened? Sorry, 1 second. Okay, yes, undo. So what would have happened is, So let's take I and j. So first will be 11, and then j will be 15, which is not 9. Then 11 and 7, which is again not 9. Then 11 and 3, which is again not 9. Then 7 and 3, which is again not 9. And then 2, sorry, my bad. So it will be 11 and 2, which is not 9. And similarly, we go over with 15. And after 11 and 15, at some point at 7, we'll find 7 and 2 is 9. So the worst time complexity in this case will be O of n square, since we have to go through this n element array exactly twice, right? So let's see what is some other way. Some other way might be, suppose we take the same thing, 11, 15, 7, 3, 2. We can sort it. We can sort it 2, 3, 7, 11, 15, and we check like all these elements which are larger than 9, we won't check it even. These we will only check within these elements. And how will you check it? We'll take 2 and we'll point j to this side. So we'll add these 2. If it's larger than 9, then we'll reduce j. And if it's smaller than 9, then we'll increase I, since it's sorted. So suppose there is also 1 there. So what we can do is, so now our new array looks something like 11, 15, 7, 3, 2, 1, right? And we then sort it. So after sorting, it looks like 1, 2, 3, 7, 11, 15. So we take I and j, and we see that 1 plus 15 is 16, which is greater than 9. So we reduce j. So j is now 11. So 1 plus 11 is again 12, which is greater than 9. So we reduce j, which is 7. So 1 plus 7 is 8, which is less than 9. So we increase I, which is now 2. And 2 plus 7 gives us 9, and we return it. So here our time complexity would be O of log n, which is good, which is better than our first case. But now, what if we want to do the best case scenario? What would be the best case scenario? Let me explain. So in this case, the best case scenario would be a hash map. How, you might ask? So let's take the same thing, 11, 15, 7, 3, 2, 1. And we'll make a hash map. So this is a hash map. What does a hash map have? It has keys and values. So we'll go through this thing exactly once. And for every element, we'll put that element as a key, and we'll put the value as 9 minus that element. Or better what we can do is, we'll put the value as the indices, since we have to return the indices. So index. So one second. We'll take it as the element and the indices. And for everything, while going through this, we'll check 9 minus element, and we'll check in the hash map. If that value is present in the hash map, then we'll take the 9 minus elements value and this thing's value, if this key is present in the hash map, and we'll take those both values and print it out. So how it works is, let me change the pen color. So while going through this, first we have 11. So obviously 11, 9 minus 11 is minus 2, which is not present. So we put 11 here and the value is 0. Then we go to 15. 9 minus 15 is minus 6, which is also not present in this hash map. So we put 15 here and the indices is 0. 7. 9 minus 7 is 2, which is not currently present in this hash map. So we put 7 and we put 3. 2. Then we go to 3. 9 minus 3 is 6, which is not obviously there. So we put here 3 and 3. Then we go to 2. 9 minus 2 is 7, which is already present in this hash map. So we have 2's indices is 4, and from this hash map we have index of 7 is 2. And since there is exactly one answer, we can break here and return it's 4, 2. Right? Now let's go into actual code and use this solution. So I've written the code and I'll show you. So we have first defined a hash map, which is sol map, right? Solution map. So for I in range length of nums, which is the whole length of nums, so target minus nums I in sol map, if it's present in the hash set, then we'll return it. Else we'll add that number and its indices at that element and its index to the solution map. So I've run it once, it works on all the test cases. Let's submit it. And then there is another better way to solve it, which is if you use enumerate. So if I comma, so let's check out enumerate function in Python for I comma nums in, not nums, let's name it num in enumerate nums complement or target, whatever equal to target minus nums, right? So this is the number we're looking for. Now if complement in format return I comma sol map num, sol map num, right? Else, else sol map num equal to I. So let's run it also. Operand type from int and list target minus, oh okay, it would be num. So let's run it once. What's the error here? If complement in sol map return I comma sol map complement. So it will be complement. This should work now. Yep, it's working, and we'll submit it. So this is also submitted and it beats 100%. Memory is also good. And this is how you solve 2-sum. The video might be a little bit shaky since it's been quite long since I've recorded, and well, obviously OBS is a very slow platform, but they will be very regular and I hope you will follow through them. Thank you.